All right, I think we're ready to get started. Well, hello everyone, and welcome to AES309, presented by United Launch Alliance and AWS Professional Services. We do want to say that this session is primarily aimed at anyone using highly regulated GovCloud environments, or really anyone who knows the pain of doing anything in a highly regulated GovCloud environment. But if that's not you, don't worry. Everything we're going to talk about, all the concepts and the framework, really do apply much the same way on the commercial side. And we will call those out when we get to those. Just some housekeeping notes before we get started. We will have time at the end for questions, but given the size of the room and the number of people here, we have elected to take those offline. So we will stick around afterwards, either up here on the stage, or I know there's another session. We might take it out into the hallway, so keep that in mind. So let's meet the team. First off, my name is Jeff McLean, and I'm the Cloud Security Architect at United Launch Alliance.
Hey, I'm Brian Gunner. I'm a senior consultant here with AWS Professional Services.
Hi, my name is Cody Hartman. I'm a cloud engineer at United Launch Alliance.
So first of all, we'd like to say thank you for joining us and helping us kick off what hopes to be a great week here at reInvent 2024. So first off, show of hands if this is your first session of the week. You guys are not starting off strong. Should have started here. Also, show of hands, who's excited to not hear about AI for the next hour? Yeah, that's what we're talking about. So basically, taking a look at the agenda, I want to tell you how ULA has taken what we feel is a novel approach to identity management and compliance within these GovCloud environments and use it to innovate at a rate that, frankly, we've just never seen before. By using this approach, we've been able to reduce our provisioning times from days or hours or even days to literally minutes by using this functional privileged architecture, all while maintaining high security standards and compliance posture. But before we get into all that and we hand over the keys to the IAM kingdom, I do want to take a minute real quick to talk about ULA's mission and what exactly it is that ULA does. I know because this is the aerospace and defense sector, I know a lot of you probably do know what we do. But for anyone who doesn't, I never missed an opportunity to see our rockets go to work. So, ULA was actually formed out of a joint venture between Lockheed Martin and the Boeing Space Company in 2006. And in the simplest terms, we build and launch rockets in support of a variety of commercial and government missions. We do all our manufacturing there in Decatur, Alabama, so we have access to the Mississippi River. This facility alone is about 300 acres, or about a half a mile long and a quarter mile wide. It manages about 20 rocket builds at any given time. And once the rockets leave the factory, they're loaded onto the RS rocket ship. And in 2026, we're getting our RS spaceship, which, clever, right? So then the rockets get loaded, they sail off to the Cape Canaveral, Florida, or Vandenberg Space Force Base in California, where they get assembled in a vertical integration facility and prepared for launch. The payloads on the rockets, of course, do a variety of different things. They explore the solar system. Some recent highlights of that is the Mars Perseverance rover, and also all 20 US-based Mars missions flew on ULA rockets. We also flew the NASA Solar Orbiter. And the thing is, our current Atlas and most recently retired Delta Series rockets have a history and pedigree that goes back to the very beginnings of space exploration. Got a picture there of John Glenn in 1962 in front of the Friendship 7 Mercury capsule, which was launched on a very early Atlas rocket. That was pretty cool. We also connect the world. And since we're here at reInvent, I have to mention that Amazon has partnered with ULA as one of their launch providers for their Project Kuiper, which is set to provide fast, affordable broadband internet to unserved and underserved communities all around the world. Our payloads also do things like weather control. Oh, sorry. Between us. I mean, weather predictions, using the most accurate climate data available, which also saves many lives. But the thing that I'm probably the most proud of is the work that we do and things we provide for our men and women in uniform. Things like accurate positioning and intelligence data that they need to stay safe and, most importantly, return home. In total, we've launched 163 missions with a 100% success rate, also something we're very proud of. And this is what it looks like.
At ULA, we launch rockets. With 100% success, we design and build rockets to launch spacecraft that no other company can. All rockets are not created equal. And as the industry's most experienced, reliable, and accurate launch provider, ULA delivers unmatched value. We show up every day ready to save lives, explore the universe, and connect the world. And with the introduction of the Vulcan rocket, ULA enters a new era of space capabilities with higher performance, greater affordability, and the world's only high-energy architecture rocket. Delivering any payload, at any time, to any orbit, our tireless drive to improve and our commitment to the extraordinary is what makes us ULA.
Told you I love seeing that. So even though we've been launching rockets for over 18 years, we've probably really gone through a lot of the same bumps and bruises that many of you either have gone through or even going through yourself, especially when it comes to cloud adoption and the cloud journey. So what were the biggest problems that we faced early on? Well, when I joined ULA about a year and a half ago, our cloud journey really was still very much in its infancy. We had just recently established our first accounts, and we're starting to build out our cloud center of excellence. But one of the most pressing issues that we encountered was the complexity of our user provisioning and how that was really hindering our work. Like I said, it was taking hours or even days and causing a lot of downtime and hindered productivity, which is also resulting in some pretty substantial losses for us, actually. We also found that once we got into it, that scaling had become a big problem, especially this identity piece that we're going to talk about today, which is also why we're here to tell you how we solved. We also found that getting to least privilege was really difficult to define. That it was mostly due to the kind of diverse nature of our user base, which could range anything from software development on flight computers and other components of the rocket, down to technicians on the factory floor. And I bet a lot of you can probably relate to that as well. Another thing we found was our workloads were also becoming difficult because of the lift and shift and on-premise mentality that was adopted early on in the process. And lastly, we just had an overall just lack of cloud knowledge amongst the user base, which also made it very difficult to answer a lot of these questions and problems that we had early on. So we definitely look for opportunities there. So how do you even begin approaching a problem like this? Well, of course, we started doing a deep dive into the policies to really get a better understanding of the environments and the user base. We had lots of discussions with users and team leads on what they're using in the cloud, how they were using it, any kind of pinch points that they had, and how they kind of saw themselves using the cloud going forward. We also used that time to talk more about getting more to more cloud-centric concepts. As with any program, whether it's mature or not, educating users during this process became vitally important. Like I said, having these conversations with the users as the architect became really exciting for me, because that's when I really got to bring in those concepts and talk about managed services, serverless technologies, things like that, and really just kind of watch their eyes light up and the gears get turning on really where their workloads could go and how the cloud could really help them, because they weren't getting that previously. We also identified some major inefficiencies in our request process, things like user accounts and service approvals, which is also causing a big kind of bottleneck for this process. We also kind of went in and started cleaning up the star permissions that were running rampant at the time and bringing in more conditional access to really kind of dial those in much better than they were. From there, I thought, like an idiot, that I could standardize this stuff a bit more and kind of get back to the basics using role-based access controls to really try to define what a ULA developer, engineer, data scientist, all that really was. But we ran into the problem that the permissions were either far too broad and therefore not meeting least privilege and not meeting compliance requirements, or they were just so tight, so dialed in that every few weeks, especially with the developers and the engineering teams as they went through their sprints, having to come in and rework those constantly. which just became a massive headache for everybody, right? Well, after working on some different architecture ideas with our architecture community of practice, which is just a cross-functional subgroup of the CCOE, we realized that we needed more help and we needed a different set of eyes on it. So we turned to our partners and friends over at AWS Professional Services to get that second set of eyes on it and to talk about what would ultimately become our functional privilege model and approach. I'd like to bring up Brian Gunter from AWS Professional Services. Brian?
Thanks so much, Jeff. It's really been an honor joining ULA. It's a very critical mission that they do, so it's really been very cool to work with ULA. I'm really excited to talk to you today because this is a problem that many of our customers face. I'm fortunate enough to work with many customers, and this is tough no matter what you're doing. And it doesn't matter if you're just on premises or if you're another cloud provider or you're with AWS. It's how do you provision your identities with least privileged permissions, but then also letting your development team develop. So let's look at our typical groups within our organization. You have your security team, which is laser focused on keeping the business alive, right? They want to keep your data sources locked down. They want to prevent exfil. They want to do all these great things that protect our businesses. On the other side of the coin, we have our development team. Our development team wants to move fast and break things, and probably why a lot of us are here this week at reInvent is we want to learn the coolest new stuff and just stay on the bleeding edge of technology. So here's a common scenario. Development team gets a brand new AWS account. They go to the security team. They say, hey, I'd like to get permissions. Can you write me some policies to get me access to this account? Security team says, well, what permissions do you need? Development team says, I don't know, I've never even used AWS. How could I possibly know that? Security team says, well, access denied, tough luck. So how do we get past this impasse? How can we intelligently allow our developers to develop and do cool stuff and keep our organization safe and our business going? So the first step here is something that's called effective permissions, and this is really the start of our solution. Our three pillars here are based off service control policies, identity policies, and boundary policies. And kind of in the Venn diagram, where it all meets in the middle, that's your effective permissions, okay? And if you're not familiar with these policies, it's fine. We're gonna take a deeper dive here in just a minute on what they all mean. So where do we kind of deploy all this stuff? At ULA, on the top left hand of this diagram, we have what's called LZA. We have an LZA pipeline, and that's an AWS solution called Landing Zone Accelerator. This can do a number of things. The LZA is great at provisioning governance, your security, and optionally your networking. Today we're just going to talk about a subset and how we can deploy our boundary policies and our service control policies. So on the right-hand side, you see the OU there. That's our organizational unit, and a service control policy is attached to that. And that's done through LTA, through AWS organizations. And then in our dev, test, and prod accounts, your mileage may vary here, how you set up your accounts. We have our boundary policies, which are attached to our different roles. On our bottom left-hand side, we have our AWS IAM Identity Center. And this is like an identity management service which can optionally integrate with third-party identity providers such as Active Directory. That's kind of how we do it at ULA. How that works is we have permission sets that are defined in IAM Identity Center, and in these permission sets are our IAM policies. Once you get all that working, that deploys your roles in your different accounts. So if you look at our dev, test, and prod accounts here in our example, those roles are provisioned by IAM Identity Center. And that's basically like when your employees go, or users, or whoever it may be, go to log in, they'll assume these roles underneath the hood. Is kind of how it works. So that kind of gets to the root of the problem. How are these policies defined? Where do these come from? The security team write them, the development team write them. It gets to the root of the problem of this. This is kind of the hard stuff. So we're going to walk through each of these: identity policies, service control policies, and boundary policies. So in our examples here, the green little graphic means you're allowed to do something, red means you're not. So our first layer is our identity policy. When you first start with AWS, this is probably what you're familiar with in terms of an IAM policy. It defines a list of actions which you can affect different resources with an optional conditional on it. Okay, in our example here, it's just a big green slab, so this is going to be like a power user identity policy, something like that. Our next layer is we tack on some service control policies. So there's a few things about service control policies. Number one is it's very powerful. And what I mean by that is if you have a conflicting policy and a service control policy and a boundary policy or an identity policy, the service control policy always wins. Service control policies even affect your root user. Okay, so they're very powerful. Because of that, if you stand up an AWS organization, you need to be careful because we actually don't implement service control policies on your management account because then you can lock out your entire enterprise. Okay, so it's something to be careful of. Whoever you provision and allow access to your management account, there's very privileged role, so be careful with that. You'll note in the background here, it's still all green. So what does that mean? By default, when you stand up your organizational service control policies, there's a default SEP, and we're still using those at ULA. The default SEP just states anything's allowed, all right? So you can take that away and actually make service control policies all allow-based only, okay? But what we do is we use our service control policies to implement our security policy frameworks by sort of prescriptive and surgical deny statements. So things like, I don't want my developers to stand up an internet gateway. I don't want my developers to create an EC2 instance without the proper tagging, that type of thing. That's kind of how we're implementing our SCPs at ULA, and that helps us implement our security frameworks at an enterprise level. Okay, so as long as you're generating accounts and new users, as long as they're within your organization and you have these security control policies defined correctly, they're going to take effect no matter what. All right, our third and final layer here is our boundary policy. So this is sort of like an inverse relationship to our service control policies. Everything that we define in a boundary policy is allowed, okay? So you could, for example, take 20 services that your organization has vetted and you're like, yeah, developers can play around with this, it's fine. They meet our security policies. You could define those in your boundary policy, and if there's new services that you're not sure about, you just leave them out, and then they're automatically excluded. So you see in the diagram now, everything within this oval shape is allowed, it's still green in there, and then everything outside of it is not allowed. So now we've got this interesting scenario here, where our sort of red background is indicating an action that would violate our security policies, creating the internet gateway, whatever it may be, in your infrastructure. But then our developers have this nice green area where they can play around and, play around with lambdas or ECS or whatever it may be that they're trying to do. And they have that freedom. But then the security team, they don't have to worry about, these grave exfil dangers just right out of the gate. Okay, so they can play around safely. So where would you implement this? I'm definitely not advocating that you start deploying power user policies to all of your accounts. That would be a big mistake. And your mileage may vary here too, but on the right-hand side here, you'll see we have an account called an onboarding account. The idea is that developers come into our onboarding account, they play around, like a month, however long it takes. while they are performing their actions, CloudTrail is capturing what they're doing, and then we can use the IAM Access Analyzer to determine what did they actually do and how can we actually, determine our IAM policies. Cody's going to talk a whole lot more about that, so I'm not going to steal his thunder. But that's the general idea. Onboarding account, you have your power user role with their implemented service control policies and boundary policies, which also prevent role escalation, and then you have a nice start. I'm going to turn it back over to Jeff now. He's going to talk a little bit more about how this is implemented at ULA. Thanks a lot. There you go.
Thank you so much, Brian. Go back. So needless to say that effective permissionings, we did find was a really great approach to these problems that we're having, because it did give us the freedom to use those slightly wider identity policies, with also kind of giving all the security controls around it that we needed to meet our requirements. But we also saw an opportunity here to go beyond that effective permissioning and kind of create something new, which, using things like some different AWS tooling, a little ULA scripting, kind of around that to develop what we now call functional privilege. So kind of building on what Brian was talking about from the implementation standpoint, there's a few things. We have kind of some non-technical things and some technical things we did. So starting with the non-technical, we first worked through that Cloud Center of Excellence as that enablement organization to really kind of get out the word and disseminate the availability, the capabilities, and also the purpose of that onboarded account. We thought that was very important to just get developers in there and start working and making sure that they can kind of learn and help us kind of get what they need going forward. We also worked through the architecture COP that I talked about, because one of the functions there is to really lean on that cross-functional group to write things like standards and policies, pretty boring stuff. But we got to work on that because that really is there to kind of set the groundwork for the entire organization on how this is going to work for us. Service approval process. So the service approval process is nothing new or novel really about this. It's something that I hope all of you are doing in terms of getting things approved before you bring them into your environment, especially in the GovCloud side. But it's really something that, fortunately, we were doing from the beginning, long before I was there. But it really became the foundation and probably the most important aspect for us to be able to implement a framework like this with a high degree of security confidence. So to do this, when we get a request for a new service, that goes to the security team, and we just start doing a deep dive into that service to learn everything we can about it, right? And start writing all the controls that we know we're gonna need for it. And we put that into a document that ultimately goes to the CISO for approval. And we put things like executive summaries and service overviews, proposed use cases, but also things like thinking about the shared responsibility model aspects, like resiliency, identity encryption, things like that, that we need to know who's kind of doing what on both ends and what our responsibilities are. Also, any sort of compliance considerations we put in there. We also do worksheets for all the security controls, like the SCPs that Brian talked about, the identity policies, kind of two of those pillars. But also put in there all the config rules we need, all the CloudWatch alerts, vulnerability scanning, and even sometimes Splunk notables. It's basically anything and everything we can think of that we need to implement and put in place so that we have those guardrails for users so they don't have to think about it and security doesn't have to think about it. So basically just a word of warning about something like this. If you're trying to implement something like functional privilege or even the effective permissioning, you really do have to understand the controls you have around each of these services, because if you don't, you really are going to leave yourself some pretty massive gaps, as you can imagine. So I just want to be clear about that. Some more of the technical things as we went to implement it. Once that document gets, again, reviewed by the CISO and signed off on, we can start then implementing that permission boundary policy to roll that out to all the accounts using that LZA pipeline that Brian talked about. And then they can now start using that new service. They're no longer blocked because the permission boundary, again, is acting as that allow list to for any sort of services, assuming there are no caveats. And I bring up the caveats because, for the most part, we do try to approve services as a whole. So you can put in the policy the service : star. And that's okay with us for the permission boundary. But there have been some situations where we've had discussions with security about certain features of a service that we're just not quite comfortable with. In that case, I just want to mention that you can get more granular, like with identity policies. Same thing on boundary policies as well. So you can really kind of lock those down. The next thing was the service control policies that also Brian was talking about, acting as that standardized block list. Just to reiterate that is, again, something that is preventing the organization as a whole from doing things that's going to hurt the users and the company, like elevating privileges, deleting logs. And given that we are a government contractor and are dealing with CUI data, internet gateways would probably be one of the most devastating things that we could miss. So this approach to least privilege management also allowed us to coin the phrase, principle of leash privilege. I do love this just because it makes me laugh. But also, this actually came out of a comment that Cody made in the standards document that we wrote for it that said, and I'm paraphrasing here, that it's like having a leash that we can tighten whenever we need to while giving the users the freedom to roam and also explore while at the same time not let them run onto the streets, as it were, right? So my takeaway for all of you, it's my personal takeaway, these guys probably disagree, but if you remember nothing else from the session, remember the principle of leash privilege, because I think it really kind of sums all this up. So, like I said in the beginning, implementing this identity management strategy really has allowed us to use much better role-based access controls while still automating secure user onboarding. And to talk more about that automation and the tooling involved, I'd like to bring out my esteemed colleague, Mr. Cody Hartman.
Thank you, Jeff. I don't know if I'd call myself esteemed, but I'll take the compliment. So yeah, now I get to talk about the fun stuff, building out our strategy. This primarily is the tooling that we use to help actually build out these policies that we're talking about. Before I jump into that, I really want to emphasize what Jeff has talked about with having a good governance and strategy that has been, that the organization has buy-in of. If you don't have a good strategy, the tooling's not going to help you. And I also want to mention the architectural foundations for having those IAM policies, so having good SCPs, good permission boundaries, and all of that as a foundation is way more important than having good tooling, because that's going to dictate what your tooling looks like. Show of hands, who here has written IAM policies from scratch? Yeah, it's pretty painful. So when we started 2 years ago working with the developers, for us, it was really, we had to work with them, figure out which services they wanted to use, implement that in a policy, and then figure out, okay, no, they actually need other services as well. And we did look at using AWS managed policies, but the problem with that is really you started getting into more of that star permission set. Yeah, it was difficult to get them more granular. So we were definitely blocking our developers by trying to hit that least privilege functionality that we're trying to achieve for our compliance. So this is where we started thinking of ways of, okay, how can we actually allow our developers to innovate? That's where the strategy comes in, and that's where the foundations come in, and that's where we start looking at tooling to help us not manually write these policies and manually deploy them out, so that we can have quicker cycles with the developers who are actually in the AWS accounts trying to innovate. So when we're looking at tooling, at least from my perspective, the first place I'm going to look is AWS. And I just want to note, it says commercial side on here, and I want to be pretty deliberate with that, and I'll go into why. But when we were looking at AWS services, we're really looking at what services tie in to other services that can generate these least privilege policies. And pretty quickly, I'm sure many of you have used AWS IAM Access Analyzer, but if you haven't, I recommend you look at it. It integrates with a whole bunch of other services, not just IAM. So it integrates with like S3, CloudTrail, and others, and you can generate some least privileged policies just based off of that usage. For our use case, though, we were really keying in on that IAM. What we wanted to do is really be able to see what services a role actually uses. So tying back to what Brian's talked about with the onboarding account, having developers in a more free area where they're running actions on resources, and we're able to capture those and figure out what they're actually using rather than giving them everything. So what that gets us here is look at IAM Access Analyzer. We wanted to generate new roles and policies based off of actions that exist in the accounts. We would discover the actions in the account based off of what are known as access reports. So there's a API functionality from Access Analyzer that's really what services were last accessed and when. And it gives us a great bit of functionality there. Now we have one problem. Jeff talked about this a bunch. We're on the GovCloud side. One issue that we ran into is the functionality to generate new roles and policies has not come to the GovCloud yet. So this is where we had to really dissect what the tooling actually looks like for us and how can we actually supplement this behavior. So we're looking at essentially scalable policy generation so we can implement that functional permissions that we talked about earlier. So if we look at the left side, we really wanted to break it down into what does this tooling look like? How do we want to actually use the tooling? And we decided to actually create some CLI tools around this for a number of reasons. You could go with a Lambda function that event bridge kicks off whenever new policies get used or roles get used. But for us, we wanted the flexibility of, we have CI/CD pipelines for our developers. So we wanted the opportunity to be able to integrate it in our CI/CD pipelines and then also be able to run our tooling manually. So that was the great boon of actually creating a CLI tool. And then in the future, we may explore maybe sticking it in a Lambda layer and running it as a Lambda function, but we have all of that pretty much out of the box. The next piece that we needed to look at was really what do we need out of the IAM Access Analyzer, and it's that generating policies from those CloudTrail logs and then those the service last accessed reports. So getting those details out of AWS IAM Access Analyzer. So we start getting a flow. If you look at the right side, we're kind of building out the cycle of how we want to interact with the users. So looking at the model, which is that onboarding account, we have users are generating actions. So at first, they may be in the console. They want to spin up EC2 instances. We'll be able to capture those actions. And then as they progress and use more services, we're actually capturing those actions with our CLI tool. So that's like the next step is we're monitoring them. We're picking it up from CloudTrail and those role reports. And then we start looking at, okay, they're finished with that onboarding account. They want to move to a more permanent home. We're going to then add those roles to a permanent account. And one thing I want to note is at the end of the cycle, we're going to adjust the policies, but that's not it. We're going to keep iterating off of that policy that was created. So, as developers iterate, we need to as well. They may add new services or remove services. And so those policies are essentially a living document. They're not going to stay completely stable. So going back to that original diagram, we look at the AWS GovCloud portion and where we supplement that tooling. So what we did is we have that CLI tool, and through AWS, they have a ton of rich APIs. We're able to access the IAM Access Analyzer API to pull down those reports that I talked about, like the service last accessed. In that API, we can see when the service was last used, what service namespace it was, and what action was actually used. Analyze the role usage from IAM, and then generate and update those roles and policies. We didn't just stop there with that supplement. We actually integrated it with our code repositories, so not just reading from AWS what actions are taking place, but now we're looking at our infrastructure as code. So looking at Terraform, for example, we can see what resources will be deployed in the future. We can see what API calls it's going to make, and then generate a policy based off of that. So we can be more reactive to our developers without blocking them. Or if we look back at 2 years ago when we were having to tag along, have a session of, yeah, what services do you think you're going to be using? You will make the updates to the policies. So we're giving them way more flexibility now and being able to be more reactive to their needs than blocking them. So what does this actually look like from the CLI tooling? Really, it's a simple input. You get those the actions collected from CloudTrail and the infrastructure as code. It's pretty simple. It boils down to the service namespace and then the action that was taken. And you guys all recognize the policy out there on the right. It's essentially, it just generates that policy that's the Amazon policy standard. And we add those actions, and then you see that start resource. The nice thing with our own CLI tooling is now that we're pulling from CloudTrail logs, we can actually see what resources actually are being used in the AWS account. So if this is a bad example of this, but if there's like an S3 Git object, we can actually see what is being used and add that to the resource. Since these are post actions, at least the run instances, it's a star resource. So I want to tie this all back together. So now we're looking at how do we build out this process for functional permissions now that we have tooling. And really what we're doing is we work with our engineers that want access to an AWS account. We get them onboarded in our onboarding account. And what we do there is we work with the teams to essentially, they're playing around in the account, generating actions, and we're capturing those as needed with our CLI tooling. So instead of us manually typing out what policies they need with their infrastructure as code, we're just doing it in the background. Now that doesn't completely cut us off the hook with working with teams or talking with our other fellow engineers. We actually work with them a lot when they start getting more mature and start heading into a more permanent home direction. They start working on infrastructure as code, and what we do is we work with them. They test out their deployments. We work with our CLI tool to essentially say, okay, capture the last actions that were used over a period of days or a period of hours so that we can capture all of those actions. The cool thing about this is it gives us a lot of flexibility. So let's say they had a role that they've been in for, let's say, about a month. And they use some services that they no longer use, and we want to filter those out. By getting that window of what actions were actually used, we're able to filter out the unnecessary actions so that they're able to have that infrastructure as code be able to capture the particular actions that they need. And then we also work with them when they tear down their infrastructure, because a lot of actions, at least with our infrastructure as code pipelines, we may deploy infrastructure and then tear it down when we're done testing, or we may have clusters that we deploy, we run some jobs on, and then we tear down so that we save on costs. But then from there, we work with the teams, we get them in a more permanent account, and we deploy those generated policies and roles, and they're rocking and rolling. So that onboarding account that they've been able to work in has really accelerated their development, and it's cut down on our time too. The amount of work that we put in years ago, just writing out the policies, was crazy, just with the amount of teams and just the hype around AWS Cloud coming to ULA, put a lot of pressure on us. So it's been a good solution. Now that I've talked a lot about tooling, I do want to go back and emphasize this tooling you can go and implement now. If you're on the commercial side, I encourage you to look at AWS Access Analyzer. If you are on the GovCloud side, you may need to do a little bit of extra work, but the flow is there. The key thing isn't really the tooling, it's really the process behind it, having a good strategy. So like Jeff talked about with our Cloud Center of Excellence, we had a lot of buy-in from them in order to get our users actually empowered. And then also what Brian has done with our infrastructure, with our IM infrastructure, being able to lay down the right policies and roles so that that onboarding account is actually secure, and developers that are in there can actually go and play without running into the street like Jeff talked about. And now this is pretty much our conclusion. We have time for questions, but we're going to take them, so like Jeff said, we're going to take them offline or on the stage. We'll be here or out in the hallway. And yeah, so this is our contact information. So Jeff, Brian, and my contact. I do want to point out there is a survey in the mobile app. Please fill that out if you can. Thank you all for coming here and have a great week at reInvent.
Thanks, everyone.
Thanks, everybody.